Hi everyone. In this session, we are going to discuss about the decision properties of regular languages. Decision properties of regular languages. Irrespective of the representation of the regular languages, there are some fundamental questions that need to be answered. Irrespective of the representation, how many representations of regular languages do we have? Three representations, either by regular grammar or by regular expression or by finite automata. So irrespective of the representation, there are some fundamental questions, basic fundamental questions which are need to be answered. Those are the decision properties of regular languages. What are they? Those are the decision properties. Let's see what are they. What are these questions that need to be answered irrespective of the representation of a regular language? Okay. Now, these are the four questions. Is the given language empty? First question. Is the given language finite? Second one. Does this string belong to given language? Third one. And the fourth one is, are the two languages are equivalent? Are the two languages equivalent? That is our fourth question. There are four questions that need to be answered irrespective of the representation of the regular language. Is the given language empty? Is the given language finite? Does the string belong to given language? Are the two languages equivalent? Okay. So the first one is regarding emptiness. Emptiness. Second one is finiteness. Third one is membership property, and the fourth one is equivalence property. Okay. Now let's see one by one. Is the given language empty? How to check whether the given language is empty or not? There are some steps which you need to follow. First step is you have to select the state that cannot be reached from initial state. That cannot be reached from initial state, and you have to delete them. So you have to delete the unreachable states. If a state is not reachable from the initial state, then there is no use, right? So remove them. Next, if the resulting machine contains at least one final state, if the resulting machine contains at least one final state, then the finite automata accepts non-empty language. Okay, now first you are selecting the states that are not reachable from the initial state and you are deleting it. After this concept, if the resulting machine, if the resulting automata is containing at least one final state, then the finite automata is going to accept non-empty language, means your language is not empty. Suppose if the resulting machine is free from final state, means there are no final states at all in our finite automata, resulting finite automata, then the finite automata accepts empty language. First you have to select the states that are not reachable from the initial state and you have to remove it. Now if this result contains final state, means finite automata accepts non-empty language. If it does not contain empty final state, means the finite automata accepts empty language. Okay, by this you can find out whether the given language is empty or not. Okay, now what is the next question? Is the given language finite or not? Is the given language is finite? Now let us see. First step, same step that we have used in for emptiness, right? Select the state that cannot be reached from initial state and remove them. Unreachable states are removed. Next, select the states from which we cannot reach the final states, which are dead states. The states from which we cannot reach the final states are called as dead states. So let's select them and remove them also. After removing it, if the resulting, after removing the unreachable states, after removing the dead states, if the resulting machine, if the resulting automata contains any loops or cycles, then the finite automata accepts infinite language. If the resulting automata contains loops or cycle, means it accepts infinite language. Now, if the resulting machine do not contain any loops or cycles, then the finite automata accepts finite language. By this you can find whether the given language is finite or not. Okay. Next question is, does this string belong to given language? This is membership property. Let M is a finite automata that accepts some strings over alphabet, and let W be any string defined over some alphabet. Now, if there is a transition path in M, in finite automata, which starts at initial state and ends at any one of the final states, then you say that string is a member of finite automata, means which is a which belong to our given language. Otherwise, it is not a member. It does not belong to our language. Okay, there is a finite automata that accepts some strings over an alphabet. Now W is our string. We have to check whether this W belong to our language or not, means whether it is getting accepted by the finite automata or not. If there is a transition path in finite automata M, starting from initial state, ending with any of the final states, then you can say that W belongs to our finite automata, means the string W belongs to our language. Otherwise, you can say that it does not belong to our language. In this way, you can answer this question. Okay. Next, what is the next question? Are two languages equivalent? Two languages are given. You have to find whether they are equivalent or not. Suppose for two languages, you have designed two finite automata. Suppose let two finite automata are M1 and M2 are said to be equal. When they are said to be equal, if and only if they accept the same language. If two finite automata are accepting same language, means both are equivalent, right? So how to find both finite automata are equivalent means you have to minimize the finite automata. You have have some steps which you need to follow in minimization of automata, right? So you have to minimize the finite automata, and that minimal deterministic finite automata, what you get the deterministic DFA, the minimized DFA will be unique in case of finite automata. In this way, you can find whether two languages are equal or not, because language is represented by finite automata, right? So by minimizing the finite automata, the last minimized DFA, if they are unique, then you can say that both languages are equal. Okay, so in this way you can answer this question. These are the four properties, four questions that need to be answered. Okay, irrespective of the representation. Once again I'm saying, okay, thank you. These are the properties, decision properties of regular languages. Thank you.